We're recording again. Apologize for the little blip there. We'll make sure we don't share this URL publicly or don't admit anybody unless you know them, unless they're a close personal friend. Yeah, back over to you, Austin. Sorry to mess up the flow there. Let's go.
Yeah, no problem. Just since we're starting a fresh recording, the key things here are basically that we're talking about Helm. We're talking about how you can use Helm to automate your deployments, how you can deploy to OpenShift with as little friction as possible, and how you can gather some of those requirements that are out there to create Helm charts. So that's pretty much where we landed. So requirements can be mapped to objects, right? So you have build config, image stream for builds, and then you have lots of different resources, both coming from Kubernetes and native to OpenShift, to map those requirements out into objects. Obviously, you have deployments where you can create things like health checks and obviously specify the image that you're trying to deploy, volume mounts, and depending on what operators, what third-party tools you have, things like Vault integration, things like App Dynamics. There's lots of cool things that you can do with deployments. There's also services that you can use to connect pods within OpenShift. And obviously, there's routes to allow ingress from outside the cluster, config maps to configure your application, so on and so forth. So there's a lot of different objects here that a developer and then an app team needs to be familiar with in order to even get an application, well, first of all, built, but also running on OpenShift. So creating objects is hard, right? There's a couple ways you can create objects. There's the imperative way of just using OC create or kubectl create. That's fine. That's usually okay. The problem comes when you have a little more complex use cases, like you do want to create sidecars and init containers. It's a lot easier to be expressive using YAML. And then, of course, what we recommend to our customers is, check that YAML into Git, and then all of a sudden you have a GitOps model where you can deploy straight from Git, and Git is the source of truth. So I'm going to assume that we want, declarative, that we want YAML as opposed to OC create commands. But let's say that you want to build an application, so we want to create a build config. There's a couple of different things here that a developer needs to think about. First of all, your company probably has some kind of standard labeling policy. That's usually what I've found with my customers is, they want to have a standard labeling policy. You may not be aware of what that is. Wouldn't it be nice if those labels were just injected there for you automatically? And of course, there's a lot of different ways you can handle that, but Helm is one way where just hard code those labels into your chart, and then, a developer would never have to worry about that. You also need to be familiar with how a build config works. I mean, there's sources and there's strategies. I don't know about you guys, but when I was first learning build config, it took me a long time to wrap my head around all the different types of build sources, all the different types of build strategies, and how the two kind of intermingle with each other. And using a tool like Helm, we can abstract a lot of that complexity and even limit the choices that they have. Maybe that your developers are always going to, want to use a Git source. Well, you can just kind of hard code in, Git source in your Helm charts. Developer doesn't even need to be aware of any of the other types. If you see that fit for your, use case, obviously it differs. And then of course, for strategy, there's different types of S2I images. Your developer needs to be aware of what value to provide if they want to build a Java app or a Node.js app or Python. What if you could just kind of provide them this high-level options of Java, Node.js, Python, and it could just generate that whole strategy for you? Kind of moving on a little bit to deployments, so the other side. Again, there's a lot of different things that you need to consider. Selector labels, making sure that your selector labels are consistent across your pod spec and your service. Network policy can fit into there as well. Of course, you have to configure appropriate health checks. Other things here that I haven't shown, like additional sidecar containers and init containers and volume mounts. There's a lot of things to consider here that you could probably abstract for your users to make it a little bit easier for them. So we need a simpler way to deploy complex applications on OCP with as little configuration as possible. I'm sure this is said by a lot of people. That's definitely my experience with customers. We just need a way to deploy on the platform with as little friction as possible. And so this is where Helm really shines. So in case you're not familiar with how Helm works, I'm going to just kind of go over some really high level features of Helm, and then we'll really drill into the technical bits of, how can you design your Helm charts? How can you implement Helm charts in CI/CD and really provide value? So Helm serves as a wrapper around different resources. You can kind of think of it like that. And the wrapper is called charts. I think they call it charts because of like nautical charts. That actually, I've been working with Helm for probably a couple of years now. And that just now occurred to me. It's like, oh, nautical charts, cool. But it serves as a wrapper around those resources. So one single command, Helm install, can create for you a deployment, config map, service, route, any other types of resources that the Helm chart developer deems necessary for your type of application. And it allows those YAML definitions that I was showing you earlier to be dynamically generated. So in a Helm chart, what you'll see is, if you want to call it, hard coding, you'll see a lot of hard coding, a lot of boilerplate in there, right? Like API version kind, maybe source type you want set to Git. But what you can allow users to do is specify parameters, which are called values in Helm. So, if I want to build an app from Git, I need to know the Git URI, I need to know the Git ref. Going down there a little bit, what I was talking about earlier, if you want to build a Java app, let's just template in, name Java 8 for the developer. All they need to say is just Java. If I want to build Python, Helm can generate in the appropriate Python image, but to the developer, it says, hey, I just want to build a Python app, right? On the right, something a little cool, that you can do with deployments. Obviously, you can generate, the regular deployment spec as well. But let's say that you have Vault Injector in your cluster. One really cool thing you can do is just have your users say, hey, do you want Vault enabled or not? Is Vault enabled false? Okay, well, we'll leave all those annotations out. Vault enabled true. Well, let's populate in all those annotations. And then all we need is just two things from the developer. What's your Vault role? And what's the console template so that we can render those secrets out in a format that your app can actually understand. That's a lot easier user experience, and in my opinion, than having to provide all of those annotations. So users can configure their installations using values. So what you do is you create a values file, and so this is basically your parameters that you're using to configure your Helm chart or your Helm installation. So you can see there, okay, my image I want to deploy, it's called Java app, and then the tag is 1.0.0. I want one replica, and if you have a Helm chart and you have a use case for Vault, maybe you have a Vault stanza, and then again, you could have Vault.enable true, Vault.role, Vault.console template, and all of those things will allow you to fetch secrets from a Vault instance without actually exposing those secrets, in Git. So as you can see there in the console template, right, .data.username, .data.password. So some really cool use cases that you can use with Helm. And of course, to install that, Helm install my app, give it some name, chart repository /Java. We'll get into that a little bit. Helm charts are saved in Helm chart repos, and then you can refer to that, using a certain name. So in this case, just an example, chart repository. Java is the name of the Helm chart, and then -- values, the values file that the user provides. One which is kind of cool thing that Helm can do, it can perform upgrades and it can perform rollbacks. So let's say all of a sudden I want to disable Vault integration for this particular Helm chart. So set Vault.enabled to false, and then I can say Helm upgrade my app Java -- values. And so what it does is it gives it another revision. And then if I want to roll back to where I had set Vault to true, then I can say Helm rollback revision 1. So that's kind of a cool feature there of Helm as well, built-in lifecycle management. Okay, so let's get into using Helm in the enterprise. So your DevOps team or your OpenShift team, they need to provide a couple of things for developers interested in onboarding onto OpenShift. You need to provide a way for teams to easily build applications in OpenShift. So if we kind of convert this into Helm requirements, Helm chart for performing builds in OpenShift would be really nice to have. And then on the flip side, for deployments, you're probably going to want to provide a way to allow them to easily deploy their applications. And you can create a Helm chart to allow them to do that as well. What I've done with my customers that has been really, really successful is creating a Helm chart repository of what I just like to call off-the-shelf Helm charts. So let's say that I want to build an app in OpenShift. Maybe I'll grab the builder Helm chart from the chart repository, plug in my values, install that chart, and then all of a sudden I have an image stream that now I can deploy. So now grab the Java Helm chart from the chart repository, install that. So we're talking very generic Helm charts that your DevOps or OpenShift team maintains for app teams to use. And then as a DevOps team, you need to ensure that these Helm charts are easily installable from a CI/CD pipeline. So the hands-on user experience is great, but automating that is even better. And really, that should be the end goal. Is how can we automate this with as little friction as possible as well. And then of course, you should make sure that you're also testing and releasing your own Helm charts, versioning those out. As a DevOps team, say you have a generic Java Helm chart, you want to make sure you're versioning that out so that in the event that you make a breaking change to that by accident, or on purpose, right? Sometimes you do have to make breaking changes. Your users aren't immediately impacted. They can keep using the older version of the chart and opt into the upgrade when they're ready. So those are some things to consider. So let's assume that you're an app team and you are leveraging this Helm model. Okay, so there's Helm charts, there's generic off-the-shelf Helm charts saved in a chart repository, and you want to leverage those. A typical project structure that I like to recommend is, have your normal source code files there, right? For a Java application, it's your source folder, your pom.xml, or your Gradle.build. But also, you might want to have a .helm folder or just a Helm folder in there containing your Helm values. So that's your configuration as code in your Git repo. So under your build folder, maybe you'll have your values to configure the builder chart or the chart enabling you to perform builds. You might also have a deploy folder under there enabling you to configure, the Java chart or whatever application chart it is that you're really trying to deploy. And of course, you can make this a little more complicated. Maybe there's different environments that you want to deploy to, and in each environment there's slightly different configuration. You can separate this out under the deploy folder. You can have like a deploy/dev test staging prod and have values under there specific to those environments. Then maybe outside of that, just under deploy, you could have like a common values, right? So you don't have to redefine the similarities underneath each of those. So there's different ways to configure it. The idea is that as long as you're consistent, as long as you recommend a consistent approach for dev teams, it becomes very easy to automate. So here's kind of the high-level architecture, and we'll get into this during the demo. This is what I'm going to show during the demo. So think of two different entities here. So Jenkins or your CI/CD tooling, and then a Helm chart repository. Helm chart repositories, those can be a variety of things. That can just be simply GitHub pages. Maybe you serve your Helm charts through a GitHub pages static site. It could be Apache or Nginx or any web server really can serve Helm charts. And those Helm charts are just saved in there as just tar balls. And then the user just basically downloads those using Helm and installs them. So that's the Helm chart repo. And in that Helm chart repo, again, your kind of off-the-shelf charts, right? Your builder, Java, Python, whatever other charts your organization needs could be in that Helm chart repo. And then in Jenkins, for example, a standard kind of pipeline might look like clone the source code, install the builder chart. And so, what it does is it reaches out to the Helm chart repo, downloads that chart, and then installs that builder chart onto OpenShift. Start your build using OC start build, right? Because the builder chart just creates the build config, but you actually need to start the build. So that's when you invoke OC start build. And then once that image is built, install the for example, the Java chart or the application chart to actually get that application deployed onto OpenShift. And of course, you can split this using different tools. You can use Jenkins for the clone source code and build side of it, and maybe use something like Argo for actually installing the chart. I've always just used Jenkins. That's always been the tooling that my customers have used, but obviously Argo is a very popular option these days, and would definitely recommend that for the CD side. So let's get into a little bit about design. We've been talking about this kind of high level concepts. Let's start drilling into a little bit about how you can design this kind of user experience behind enterprise Helm charts and generic Helm charts for dev teams. So a builder Helm chart might look like, well, it's actually going to look pretty simple. Underneath your templates folder in your Helm chart, you'll have likely two resources. You'll have a build config, probably an image stream if your users are leveraging image streams. And then I always like to recommend having, have a really good README, document out all the parameters, all the values, give some examples, and then have a change log. This is a really big thing. As you make changes to your Helm chart, your users are going to want to know kind of, what changed from previous versions. So definitely you're going to want to make sure that you maintain at least some records so that users can know. And some things to consider as you're designing the chart, what SQI images does your enterprise use? Are you using just kind of the out of the box, samples operator provided SQI images? If so, then that's great. Template those out in there. Maybe you're pulling directly from, the Red Hat Container Catalog or from Quay. Template those in there as well. So your users don't have to know the full URL. They can just say, oh, just give me Java or give me Python. Whatever that is. Another thing to consider, are there environment variables required for proxies? We see this all the time with Maven and Gradle, creating environment variables to allow you to reach your enterprise proxy. You just template that in there. Your user doesn't even need to worry about it. Things like image change triggers. Do you want to leverage, do you want to run a new build whenever the image changes? And if so, you can create an easier user experience around that. And just kind of think about, what are some other fields that you can kind of default to reduce the amount of config. Kind of like I was saying earlier, maybe you just want to leverage git source. Okay, we'll just template in git source. Your users don't even need to worry about binary, custom, the other kinds. Really kind of see what you can kind of narrow down and decide what are the things that you want your users to access, and what are the things that maybe you don't want them to, for maybe security concerns or others. And then as an example here, here's kind of what an example Java chart could look like. And so obviously when we're talking on the application side of things, there's a few more things to consider. So deployments for actually getting your app onto the platform, but then config maps for configuration. Maybe your app needs to be backed by persistent storage, services routes, service accounts if you want to have one service account per app. And when you're designing this, think about what are some of the integrations that you want to black box for your users. So kind of like what I was talking about earlier with Vault. When I'm working with my customers who want to integrate with Vault, I don't want them to have to worry about writing a init container, sidecar container, create annotations, whatever the use case is to get Vault running in your enterprise. I don't want them to have to worry about creating all those things. I want the experience to just be like, hey, do I want Vault? Yes, I do. But here's the minimum things that you need to know from me. You need to know my role, and you need to know kind of the format that I want to generate my secrets. And that's it. Let Helm do the rest of the work. App dynamics as well. I've implemented app dynamics using init containers, and I've also implemented it using annotations if there's maybe some kind of operator or injector in your cluster. Template those things out as well. App dynamics.enabled equals true, and then whatever minimum required configs that you need to know from your user, and then don't expose any other configs. And then, what are some other fields that you want your users to configure? Maybe you want to give them the opportunity to provide freeform volumes or freeform, extra containers, etc. So really kind of think about what your requirements are and design your Helm chart based on that. One thing I think that's worth considering, as you create different Helm charts, you're bound to end up with some boilerplate between those. So one example is like labels, right? You want all of your apps to have a consistent labeling. Well, you don't want to have to copy paste those same labels in every single resource across your Helm charts. It'd be great if those were captured somewhere and you can just kind of reference them, kind of like a function. You don't want to have to redefine those. Helm has a great feature. It's called library charts. And what it allows you to do is do just that, capture boilerplate in a completely separate Helm chart. It doesn't actually deploy any applications, but library charts are literally just for capturing boilerplate and for providing a set of templates for you to reference in your other Helm charts. So the example here for labels, right? Maybe you want there to be a helm.sh/chart label, app.kubernetes/version, app.kubernetes / managed by, you can just pretty much package all of those in a template, and then to refer to those in your generic Helm charts, you just say, include common templates.labels, right? Maybe that's the function that you created there. For services, include common templates.service ports, right? So now you don't have to template out that whole port spec and all of your service templates across your Helm charts. Just refer to that, and then as you need to make changes across the board, make changes in your library chart as opposed to every single chart that you develop. I do want to talk about, I think there's a conversation to be had of what ratio do you want your users to pretty much fit into this model? I always kind of vouch for the 80-20 model. I think that if 80% of your developers, 80% of your app teams can fit into this kind of enterprise, off-the-shelf Helm chart model, I think that's really good. For that 20%, maybe their use case, maybe it's just too complex, or maybe it's just so different from what those other 80% are doing, that maybe it just doesn't make sense to kind of fit some of those features into those Helm charts. You still don't want to just leave them hanging. And I think this is where library charts really come in handy. They may not be able to use the off-the-shelf Java chart, but they may be able to leverage your templates in the library chart to kind of bootstrap their own chart development so that they don't have to start from scratch if they wanted to write their own Helm charts. So I think that's something very important to consider. Kind of 80-20 for your builder and Java and Python charts, but provide something for those other 20% that maybe don't quite fit into that model. Okay, and so now time for the demo. And during this demo, we'll go over a little bit more of the technical details. I'll kind of show you just a very simple generic builder chart, very simple generic Java chart, and then we'll kind of walk through the steps of a Jenkins pipeline, kind of look at how that's developed. So let's see here. Let me exit out of this, and let me open up VS Code here. Okay, so let's look at some of the code first, and then we can look at kind of just an example pipeline run, look at kind of how that works. So let's say that I've got a sample, and if this is too small, guys, definitely let me know if the text is too small to see it. So let's say that you've got your example, your enterprise Helm chart repo with generic Helm charts. So in here, I've got a builder Helm chart and a Java Helm chart, and of course, you might expect this.
We see your screen, Austin. Sorry, we only see it in the presentation slide.
Oh, my bad. Okay, tell you what, let me stop sharing real quick. And I thought I was just kind of sharing whatever on that screen there. Your entire screen. Okay. I think I'm sharing it now. Again, let me know if the text is too small.
You might want to just ramp it up just a little bit.
Okay.
Just zoom in, yeah, if you can.
Yeah, I'm trying to see how I can. Oh, perfect.
There you go.
Okay.
Yeah, great. Thank you.
Awesome. Yeah, you're welcome. I'll make it even a little bit bigger than that. So, the first time I ever had to do that, I'm like, man, I hope that Control Plus works. So let's imagine that, Konveyor Helm chart repo is your enterprise Helm chart repo, just kind of your standard generic Helm charts for your application teams. So here's an example builder chart. Think about the chart.yaml here. Every Helm chart needs a chart.yaml. And so, name here is builder, give a brief description, a Helm chart used to build an image in OpenShift, for example, right? Of course, your versioning here. Your values here that you're going to provide, you want to be very clear about which values are required, which values are defaults. So if I'm building an image, in OpenShift, I need to first expect users to provide me, well, hey, what's the name of that image that we want to actually write, that we actually want to build. And so maybe, I'll expose like an image.name here and an image.tag. And then, the user can provide this in their values. Okay, well, my app that I want to build is called Spring Rest. The version that I want to give it is 1.0.0. Get URI and ref. If we want to do a get source build, well, we need to know the URI and the ref that we actually want to clone. We can usually assume, okay, maybe we want to just make master default so that they don't have to provide that every time unless they want to do a feature branch or whatever. So in here, okay, well, my URI, this is where I'm pulling from, and this is just an example Spring app that we have in the CLP. And then application type. Do I want to build a Java app? Do I want to build a Python app? And of course here, I say Java. So for my templates here, and I'm not going to go through all of this obviously, but I'm going to try to hit on some of the high level things here just to kind of show you guys kind of some of the key takeaways. So, for your output image, you can say the values.image.name that I just provided. So, Spring Rest, image.tag for 1.0, and then maybe in here you've got your application type here, right? So if it's Java, I want Java 8. If I say Python, then I want to create a Python 3.6. And I guess maybe a prettier way to look at this is I can kind of show you what this looks like when it's templated out. So let's just say Helm template, my Java app. And then I can say builder. And then for my values, maybe the values that the user is providing is these basic values here. So what Helm ends up generating for you is a build config here with the values here that you provided, the name, there's my URI, it's pulling from the Spring Rest repo, and then I've got an image stream here, Spring Rest. One cool thing that you can do with your user experience is you can set certain gates, in your Helm chart repo to kind of guide them to providing the right values. So like one thing that I did in this, let's say that I left tag blank. One cool thing that you can do is you can create a required check in your Helm chart. So I got an error here. It says value image.tag is required. And that happened because in my Helm chart, I have a check here where I'm invoking the required function and I'm giving it a message to say to the user if I don't provide my value. I realize that this is actually URI. Tag was up here, but pretty much the same format here. And that will make sure that the user provides these values. Another example that I have here, let's say that I provided an invalid application type. So, let's go back here. Let's just say 1.0.0, and let's say, maybe I say Node.js, but I don't have support for, the DevOps team maybe doesn't support Node.js yet for this Helm chart or for the generic charts. So what you might see here is another error. It says fail. It says value application type must be either Java or Python. And that happened because I created a fail invocation here that basically does a check on the required types. So really what I'm just trying to show you guys is an example of kind of how you can provide kind of a guided user experience with these Helm charts using the required and fail function. You know, kind of flipping over to the Java side, kind of the same things that you'd expect. You know, your users need to tell you what image that you want to actually deploy. So pretty much the same value that you provided for the build you want on the Java side as well. You know, maybe you want your users to be able to specify the number of replicas, or maybe you want to default to one. You know, ports, your users are going to need to be able to tell you, you know, what ports have your application exposed and which ports do you want to, you know, open up to your service and to your route as well, if you choose to enable that. And notice here that, you know, what I like to do is I like to leave comments above most of my values here, right? Just so that a user can kind of go into this values file and just see, okay, well, you know, what does replicas do? Okay, well, it's the number of, you know, replicas that I want to deploy. Maybe a better way to say it would be number of pods. So I'm not, you know, using the same name there, but you know, ports for more information. You know, here's the Kubernetes documentation on how to configure your you know, ports there. One thing that I will say about designing a Helm chart: be very careful about not basically rewriting the Kubernetes stack. You know, it's very easy to do that. Let's take ports as an example. What I'm doing with my ports is I'm just saying to YAML values.ports, right? Whatever the user provides there for my ports, that's what I am expanding here. It's very open-ended. It's very free form. I like to use this model for things like ports, for things like extra sidecar containers or additional init containers beyond what your chart already provides. You know, you don't want to expose values for container.name, container.image, container. You know, image pull policy, so on and so forth. What if OpenShift or, you know, the underlying you know, Kubernetes API makes a change to one of those fields? It's like, well, then you have to go in and make that change here as well. Also, what if your chart just doesn't create an image pull policy? Well, then someone has to say, hey, Austin, can your chart support image pull policy? Now you have to go in your values, plug in image pull policy, template that out. Well, you kind of have to decide where the line is. And for things like that, I like to just say, okay, you know what, whatever you give me, just expand here. And OpenShift will tell the user if it's improper, right? There is built-in you know, mechanisms there to make sure that the user provides the correct field there. So try to keep that in mind. It's easy to get carried away with the values that you do support. Okay, so that's kind of just a quick look at the Helm charts. Kind of what a sample app will look like. You know, again, here are basically the standard, you know, application files here. So source, you know, your git ignore, your Jenkins file, so on and so forth. The thing that I added here is the Helm folder, and so that's your, you know, your build values. So essentially, to create a build config in an image stream, you're looking at, you know, 7 lines of YAML here with this particular Helm chart. I think that this is a huge value add to the customer. This is so much easier to configure, especially once your values are well documented and you have examples, than to, you know, have your users create a full-blown build config. Of course, deploy as well, right? You know, we're potentially creating a lot of things here, you know, deployment, service, route, so on and so forth. In this particular example, 8 lines of YAML to create, you know, your deployment, to create application properties in a you know, config map. Again, I think that this is a huge value add to the user. So quickly, I want to look at an example pipeline. Actually, maybe just a very quick high-level overview of the Jenkins file might be good to see here. So in a Jenkins pipeline, you could have like a setup stage where you tell Helm, hey, where is my Helm charts repo? Okay, in this case, I'm just kind of serving these charts from GitHub pages right now. For build, tell Helm, okay, Helm upgrade my application, my builder chart here, and then provide the values in the Helm folder, right? So that's why I recommend, maybe keep your values underneath a .helm/build.helm/deploy folder. And then this can be very standard across all your pipelines in the enterprise. If it's consistent, you can try to, it makes it a lot easier to try to create examples for your user, and maybe even create some kind of standard out of the box pipelines for your user if it's very consistent like that. And then of course for deploy, pretty much following the same idea, install my Java chart using the Java values. And so I'm going crazy here with the highlighting. There we go. Your .helm/deploy/values.yaml values there, right? And so what this looks like in the Jenkins pipeline, there we go. Let me know if you guys can't see this. I know we got mixed up with the VS Code. So in a pipeline, what you'll see here is okay. So right, Helm repo add. I'm adding my enterprise Helm chart repo so that I can refer to those charts. For build, what I'm doing, right, is I'm installing the builder chart and providing those build values that the user provided. And then I am invoking OC start build here, just following those logs all the way through till they're finished. Jump ahead to our next command here. Once the build is finished, right, it pushes to that image stream. Next, Helm upgrade install the Java chart, providing the Java values here. What Helm actually does when you provide the wait flag, this is a really cool feature of Helm, is that it will actually wait until your readiness probe passes. So your pod is actually recording as healthy. So you kind of get a built-in smoke test there, which I really like, and it's obviously very helpful in a pipeline. You can sit and wait at that deployment stage until you're healthy, and then you can continue to whatever else you're doing. And of course, in this case, this was the last step, but if there was more, it would have just sat there and waited. So yeah, I think that's pretty much it. We went over a lot of good stuff, kind of the value that having generic Helm charts can bring to an organization, the ability that it has to create easy, simple, pipelines and automation that your user can leverage. And hopefully you can see how Helm is a path of very, very low resistance to onboarding onto OpenShift. So that's pretty much it, guys. And 10 minutes left. Happy to answer any questions that you have.
Yeah, thanks, Austin. Let me just jump in before we go to Q&A because I know some people may drop. Just to let you know, I did put a link in the chat. If you fill out a survey, we'll subscribe you to the community Google group, and the first 100 people will get a T-shirt. So, seeing as there's 83 people on, you can all get one. Don't send it to your friends, please, if they didn't actually attend. But really appreciate Austin the presentation today, and all of you being here as well. And now we can open it up to Q&A. I think one of the questions from Burr Austin in the chat was just, do you have a link to that GitHub repo with where you were giving those Helm chart examples?
Yeah, good question. I will push that to GitHub. I was using just kind of like a Red Hat GitLab for that. I'll get that set up, and James, I can ping you when that's ready, and then we can make that part of the email that you'll send out.
Cool. Yeah, we could just post it to the Konveyor group and mailing list.
Okay.
Any other questions, comments?
Hi, Austin. This is Ashok here. That was a great presentation. Thank you. Is there any way we can order the resources in which it gets installed in Helm? Like, for example, you want to install a SEC before installing, creating a service account, and then further.
That's a very good question. So Helm has a built-in order in which it deploys resources. So it knows that you need to create config maps and secrets before you create deployments, for example. I think it also probably creates services before deployments. Regardless, there's an order that it has. Now, here's part of the problem. When the resources that Helm understands are Kubernetes, base resources, right? So when you talk about things like SCCs or OpenShift specific resources, it is, it doesn't understand those resources. So I believe what it does is it deploys those things first. It just says, okay, actually, I'm sorry, I think it deploys those last. So it just says, hey, I don't know what an SEC is. This is just gonna be the last thing that I deploy. If you want to force it to deploy first, there is a concept of hooks in Helm, so you could create what's called a pre-install hook and install everything that you need to force it to install first. Yeah, hopefully that answers your question.
Sure. Yeah, I've tried the hooks, but one of the challenges I've seen is that I think it does not delete things that are created with a hook or something like that. So I was just wondering whether there was any other alternative that we are missing. Yeah. Thank you.
Yep. Any other questions?
All right. I think we're just getting some asks to share the slides. Yeah, we will. I'll put those together with the recording and send it out to this list, and we'll also post it on the site. So, but let me see. I think I could just find them here and put them right in the chat too.
Cool.
All right. Well, thank you, Austin. Thanks everybody for joining, and we appreciate it. And we'll look forward to seeing you on future calls. And happy Friday.
Happy Friday, everyone. Thanks a lot.
Thank you.
Thank you.
Thank you.